So here's a slightly more complicated problem that you have to simplify, in that you have p subtract a big fraction with a bunch of fractions inside of it. So again, like with any other fraction problem that we've worked with, if you have fractions and fractions, the goal is to get any separated ones into a single fraction so that we can invert and multiply within the larger fraction. So we'll work with that first in trying to add p over q plus q over p. They have different denominators. One's a q, one's a p, so we'll give each other the denominators. We'll do p to the left fraction, q to the right fraction. So what you have is p squared over pq plus q squared over pq, and that will become p squared plus q squared over pq. And again, no, you cannot go through and start canceling p's and q's because the top has an addition in it. So you got to leave it. So what we have now is p minus q over the p squared plus q squared over pq. Okay, so now that we have a value divided by a single fraction, I can look at that as q divided by p squared plus q squared over pq, and I can make that q times, and then I can invert and flip, do the reciprocal of pq over p squared plus q squared. So the top becomes pq squared, and the bottom becomes p squared plus q squared. Okay, so now we have p minus that prettier fraction, p minus pq squared over p squared plus q squared. Okay, so now we have a single term minus a single fraction, that single fraction having a denominator. So we need to give that denominator to this single term. So I'll put p squared plus q squared on the bottom and multiply p squared plus q squared on the top. So what the numerator becomes is p cubed plus pq squared over p squared plus q squared minus pq squared, the fraction that we had to begin with. And now since I have a common denominator, I can subtract across the top. And if you'll notice, we get p cubed plus pq squared minus pq squared, and p squared plus q squared on the bottom. And the pq squared terms actually subtract to 0 because they're exactly alike. They're like terms. And what we're left with is p cubed in the numerator and p squared plus q squared in the denominator. And again, you may not cancel p's because there is that addition in the middle in the denominator. If it were just p cubed over p squared, sure, but because it's a quantity that's being added in the fraction, you may not start canceling terms out like that. So the final answer here is p cubed divided by p squared plus q squared.